Hello, welcome to my demonstrations of how to play with technology. In this example, I'm showing you this setup, which is an industrial setup that is setup that uses industrial equipment. But in this example that I'm demonstrating, I want to show educational purposes. It is done for educational purposes. So I use a motor, induction motor, an inverter from Omron, a SysDrive module 3G3FV, which is VF and vectorial inverter, very advanced, very good, with a digital interface, analog interface, so you can select, you can access velocities, command velocities with a digital code, but also jog the motor with an analog signal that is proportional, that is regulated to be proportional to the frequency of the motor. So you can have 0 to 15 hertz, 0 to 50 hertz with a signal from 0 to 10 volts. So analog and digital interface. I do that, I access that functions using a PLC system. It's not an ABB, not an Omron system, it's a Siemens system. The idea is to use different equipment so that you can see, we can do all of this not with the same brand. This is not a question of brands, it's a question of using equipment. So this is a PLC system that I like very much, S7. I'm using the S7-200 modules with CPU 215, which is fairly good and cheap. The system is connected to my PC through a serial channel, USB. The PC is running monitoring command software designed in C#. And also the software is as a TCP/IP server. So you can access the functionality of the commanding software and monitoring software from the network, from any client. And the client could be a laptop, any client in the network, a laptop, a phone, an iPad, or something that you have that can have access to a serial interface and send TCP/IP commands. I'm using sockets here, so TCP/IP commands. Also to show that all the functionality of the PLC system can be executed with a simple hardware, I put it in parallel, an Arduino board, very simple board, Uno Revision 3, which is a very simple, very cheap board, 15 euros from the market. And the idea is to show that you can do all of this with an Arduino board. That part will not be covered by this video, it will be a subject of another one. But basically, anything that you do with a PLC system, you can also do with the Arduino. So let's demonstrate this. Let me show you my screen. My screen is, this is the screen of my laptop. I have a camera. The camera is pointing to the system, so I have the system in front of me. With the motor, with a card for you to notice when the motor is spinning. You see the Arduino board here, the Uno board with the circuit to interface to the inverter. The inverter is here. So the Omron SysDrive inverter. I'm using the inverter in VF mode, not vectorial mode. The PLC is here, S7-200, normal PLC with the analog expansion module. So if I take the first application is that one that you can use to simple access this PLC through the serial channel. So basically what does this application does, you connect to the system through this port and you can change spinning, the spinning let's say rotation from forward to backward. You can stop the motor, you can enter jog mode and specify the frequency you want the motor to spin, or you can access one of the 7 registers with predefined velocities. I stored seven different velocities in memory so that I can access them from here. So you just specify what register you want to access here and click this button and the system will run at that velocity. Also, the software is always checking the I/O of the PLC. So you have here block 1 of digital outputs of the PLC, block 0, block 1. I have 14 outputs, and then I have 10 inputs. So these are the 2 blocks of inputs of the PLC. So when anything is on the PLC, you see the corresponding bit light here in yellow. So let's connect to the system. It says that the system is ready. For example, you see that here that bit 2 of the first block of outputs is connected, and bit 0 of the first block of the second block of outputs is also connected. So it's to show you how this works. Let's specify, for example, let's specify that we want to move forward, and for example, let's access the velocity stored in register 5. You see the motor will spin. I think that velocity is around 35 hertz, 35 hertz. So it will run. We can, for example, now change the spin, or for example, access full velocity first. Full velocity, register 7. It will accelerate to 50 hertz, accelerated to 50 hertz, and then we can, for example, change the spinning orientation. It's spinning forward. Let's do it backward. It will stop and then change to backward. You see, it was changed. You can also, for example, let's the motor accelerate to 50 hertz. You see that it's commanding 50 hertz over there, 50 hertz. Let's, for example, access register 1, which means motor stop, which is velocity 0. Let's enter, for example, jog mode. In this mode, the velocity will be proportional to the analog signal. So I just made a linear correspondence between frequency and analog signal. The analog signal is 0.10 volts, and the frequency, of course, is 0.50 hertz. If we enter jog mode, let's say, for example, that I want a frequency of 30 hertz in the direction that was selected, which is backwards. I can, for example, change to forward. I just stop here, go forward. The motor will stop and will go forward. I can accelerate the motor to 50 hertz. Let's wait for him to stabilize at 30, and then goes to 50. At any time, I can select a velocity from the predefined velocities. For example, I can command here 0 and go to frequency, let's say register whatever, 6, for example. And this is the bits that are commanding register 6. 4 plus 2, 6, means that I'm accessing the predefined velocities. And you can swap all this. Let's put this back to 0, to register 1, and wait for it to stop and put it in stop mode for us to try the servers and client server versions. Let's disconnect this. Then I have 2 programs here. One is a server and one is a not this one, and one is a client. So you see the same system. I have a client here and a server here. The server will work in this IP, which is the IP of my computer, and in this port. Since the client is running the same computer, not running on another computer on the network, it was just put it here for you to see. I'm saying that I want to communicate with this IP and this port, which is the IP and port of the server. If I activate the server and, for example, say that my motor M1, oh yes, I named my motor M1, motor 1, because the software was designed to control whatever number of motors you want. So this is the motor I have is motor 1, but you can say motor 2 or 3 or 4 or whatever motors you have. Let's say that I want to connect to my robot. I know that to my motor, I know that the motor is connected to COM3 on the server. So I say COM3, motor 1 connect COM3. I get the same messages that before. The software says that is ready for me. So I have the motor under my control. Let's say that I want to move it forward. M1 forward, yes. And then specify, for example, one velocity from the registers. Let's say user velocity, let's say velocity 5. And you see the motor spins with velocity 5, which is around 40 something hertz. Or it's something that was stored. You can change it. For example, if you want to spin in the other direction, you can just say stop, send that to the motor, and then go backward. It will now go backward. If you want, for example, to jog, let's put a user velocity back to user. I don't need to do this. I can just say enter jog mode, and then start sending frequencies. M1 frequency, let's say 45, for example. It will spin at 45 hertz. And basically, it's what you can do with this system. With this client, you can send commands through the network to the server that listens to you and executes the commands. Let me, just to finish this, let me just stop it, M1 stop, and then to say bye-bye from this, you can disconnect from the system. The system disconnects, and you have the system ready for another person. Oh, sorry, this server is multi-client server, so you can have several clients accessing the system at the same time. Of course, in a professional thing, it will be protected by passwords, etc. I hope you enjoy it, and I hope to see you next time.